Greetings, data structure coder. I hope you are fine. Dynamic array. This is a post-coding little chat, and I think we can learn a lot after we code. So let's jump right into it. At least that's what I always find. After I do something, I can maybe learn from that, from what I just did. And this is just food for thought. There's always different ways to code things, different ways to solve a problem, right? So this is just food for thought. In other words, a different perspective possibly. We're going to look at generalization a little bit, and we're going to look at iterator a little bit, just because I like iterator. Iterator is a nice friend. Um, One generalization that we could do, and again, this is just food for thought. We know we have to implement the dynamic list, right? Well, we can. Nothing prevents us from extending a class, in other words, subclassing, making a superclass. And the beauty of this is that if we do that, our linked list, our next project, can also extend it, and then we have shared code, or we have reuse of code, right? All right, so this is required, and this is optional, but I'm going to show you kind of what I think is kind of nice about it. Iterable list, I called it, and we could call it something else if we wanted to, but it just seemed to me to make sense. You could call it my super list, whatever you really want to, what makes sense to you there. This, of course, we can't rename that because our users are going to depend on that name, and we can't rename that. But this is our world here that we're just deciding to do. Let's jump into iterable list and kind of take a look at it a little bit. So basically, this is a class that both dynamic array and linked list could inherit from and share functionality. So we have a few abstract methods here, and abstract means they're not defined here. They're going to be defined in the subclass. So some methods there that we add in, and you kind of learn the methods that you need as you go there, as you code. So let's look what happens here. Well, first let's just talk about iterator for a second. I used iterator. You could do this generalization, this superclass here, without an iterator. You could do it just with regular iteration, and it would also work pretty good. But we're just going to learn something new. We'll look at iterator. So what is an iterator? What is an iterator? I think of it kind of like a spider or a hiker. It walks along our structure. So whether we have 3 elements or a billion elements, it knows how to walk along that structure all the way to the end. And the best way to look at a class to get an understanding really isn't the code, because code is typically verbose. What we really want to look at is like an interface, and that's Java has this beautiful thing called the Java interface, right? So a structure iterator, that's what we would want to inherit. Our iterator, let me make sure that I actually did do that. Dynamic array iterator, implement structure iterator, yes. All right. So structure iterator, 3 methods, and that is a thing, when we see this kind of thing, we think of that as a thing of beauty, because 3 is a small number, 3 is simplicity, and that's what in the coding world we want simplicity. All this iterator needs to understand, or I should say, be able to do. This spider, this iterator, this spider, or this hiker of structures, or this spider who walks along our structure, it needs to only understand how to get the next element. It returns the next element that it's walking along. So when it starts, starting at the beginning, it would return the first element, right? And importantly, then it also moves to the next position. All right. It also knows how to answer if it has another element. If it's at the end of its walk, if the spider is at the end of the structure, it would return false here. There's nowhere for it to go. Otherwise, while it's walking along, it would return true. Peek is similar to next, except it does not increment the position. It returns the current value. So if we're at the beginning of the list, again, it would return the first element, but it would not increment the position. So those 3 little methods, it seems like, well, that's a little object. It's not going to do much, but it's a very powerful little spider. So if we go to the iterable list here, let's look at again what And again, you could do this without an iterator. You could also use just normal iteration, this kind of thing that we're doing here. But I think the iterator is nice to learn, and it's so simple. So basically, I don't want to ruin your fun on what an iterator would look like, but what I will do is just show you the what I think a dynamic array iterator would have two instance variables: a list, which would be a dynamic list, and then it would have an index. It would have to know, and that's the current position basically, right? Initially 0. You know, that's what that iterator would look like. We would return the iterator in dynamic array. We have a method called iterator, do we? We should. There it is. So returning an iterator there. And we're passing in ourselves. We're passing in the dynamic array. Alrighty. And linked list, of course, would have its own iterator. It'd be a linked list iterator. Alright, so let's go back here finally. And we'll be done here. Look at a few methods that we could do. This then could be the same code, shared code, in the superclass for the dynamic array and linked list. The for each method, all it's doing is iterating over elements in this object. And let me just do something here. Iterating over the elements and then performing the action. So basically we're saying spider or iterator, please walk. Please walk along the structure and perform action function at each node, or each, I should say each element you visit. Can I type? Thank you. Thank you, spider. And when I say spider, I mean iterator. Please walk on the structure and perform the action function at each element you visit. Okay, so what does that look like in code? Very, very simple. The iterator has a very simple protocol. Almost everything we'll do will be iterator. Here's how we iterate. While iterator has next, in other words, while it still has another element in it, if it's beyond the end, in other words, then it's done, and we don't need to iterate anymore. But while it has another element, then we're gonna get the element. We can say element equals some kind of data type here. We'd have to specify 2, right? Not object, but some kind of data type we would specify. And we would say element iterator next, right? And then element do something, depending on whatever we're doing. This is the basic pattern or format of our iteration. All of our iterations are going to basically look like this. We're going to iterate while that spider still has another spot to go to, and we're then going to grab the element at that current spot that the spider is sitting at, and then we're going to tell that element to do something. So that for each, we'll see that we can iterate here, and there's the action function. We're going to, as we talked about, please perform the action function. So all we're doing is going to all the spots. Spider is going to all the spots, and it's doing the action function, which in Java is action function except. I would rather have Java have maybe a do there. It would make more sense to me, but that's what Java, the way it is, that's the way Java's function works here. I should say its consumer works here, action function except. All right, print all, even easier, because we can just call the for each method right there. We're just going to call the for each method with our print. All right, to array, that one's provided for us, I believe, so we don't need to really look at that. Map. We create a new list here, right? New elements, and it's an empty list, and we have this method called new list that, while coding, we realize we need, because the linked list and the dynamic array will answer something different in each case. The subclass must implement this method. The dynamic array would implement that method as, let's look at dynamic array new list really quick. New list, and it just returns an empty version of itself, a new empty dynamic list. And what does new empty do? returns new self. Okay, so that's all that does. All right, so let's go back here, down here to map I think we were at, and we have this new list of elements. And similarly to before, just like spider, please walk along the structure. And what we're saying here, spider, please walk along the structure and get a new element. Not typing real well today. Get a new element at each position that you walk through. Well, at each position, using the what? Using the function, we call it the map function. Using the map function. And again, we say thank you to be polite to the spider or the iterator. So walk along the structure and get the element, a new element in each position. All right, so here we're walking along and we're getting that new element by function, and Java function uses apply there. All right, and we're passing in the current element or the next element that we're walking during our walk, during the iterator's walk. All right, and we add it to the new list and return that, and we keep iterating, I should say, until we're done, until we're at the end, and we return it. All right, select, it's going to be very, very similar, right? Select is very, very similar, except we add that if statement. And we're actually using peek here to not increment until we're then passed here. All right. Reject, actually, what I'd like to do there is just reuse select for reject and invert the function there. All right. So join, again, we would use iterators for join. New list here. And we're going to iterate over our self first, right? And then we're going to add to this new empty list here. We're going to add each element. And then we get an iterator on this other list here, and we iterate over all of it, and we add to this new joined elements, and then we return joined elements. So that's just a quick little demo there of some, again, a little bit of generalization, a little bit of usage of iterator, and food for thought. So we'll talk to you soon. Thanks.